Hey guys, I wanted to show you how to do another type of balancing of a more complicated redox reaction. It's called using an acid method. So this is really the last part of this unit that we're doing on oxidation and reduction. These are the steps that we're going to use. The steps will make more sense when we start to apply them. But as we did when we wrote the simpler half reactions, we want to assign oxidation numbers and then write down which one is the oxidation, which one is the half reaction. It's a little different though because we're going to actually leave an empty space for where the electrons would be. Then you want to balance all the elements except for hydrogen and oxygen. You're going to use balance the oxygen by using water and the hydrogen by using acid and the hydrogen from the acid. Then we're going to balance the charges by putting in the electrons into the blanks, and then if needed we multiply so that those electrons are equal and conserved. And then we'll add together all of the half reactions. So here is an example of a reaction, and this is a titration that can be done where you're going to take a solution of potassium permanganate with iron sulfate, but it's going to be an acidic solution of that. And I'm not going to get into the exacts of the reaction, but realize that water is in this flask, and so is the acid sulfuric. So there would be a drastic color change when you do this, but the reaction that we're going to start with has been simplified so that only the substances being oxidized and reduced are included. So the first thing that I'd want to do is, if I follow my steps, which are here, is I want to assign oxidation numbers. So I'm going to, I know oxygen is -2. The manganese here would be +7 because the sum of the oxidation numbers has to equal -1. Here the oxidation and the ionic charge are the same. Same thing here. Same thing here. Next thing I want to do is write those half reactions and balance the elements. Well, all of the elements are balanced except for there's some oxygen that we don't see on the product side, so we'll deal with that. But let's write the oxidation half reaction, and we're going to leave that blank for the electrons. So I'm going to know that this iron here becomes oxidized and loses an electron. So I'm going to write iron 2+ is going to become iron 3+ plus some amount of electrons. And we're going to leave that blank. So the next thing would be to write the reduction. And the reduction is going to be the manganese. From +7, it gains electrons to become +2. The oxidation was the iron, +2, changing into +3. So the reduction is going to be written as the whole ion. I'm going to include the oxygen and the permanganate. Plus, I know I'm going to gain some electrons, but I'm going to leave that blank. And then I'm going to form manganese 2+. So I just, if I look at my steps, I have done step 1, 2, and 3. And now I'm on step 4. I'm going to balance the oxygen using water. So because I have 4 oxygens here, I need to put the water back into the simplified reaction that we started with. So I'm going to put those 4 waters here so that I can have the 4 oxygens be balanced, because I want to make sure I balance the each type of atom in the equation. So I start with a simplified reaction, which is what is oxidized and reduced, and then I go back and, if necessary, add water, which I just did to balance the oxygen. And then you can also see now I have hydrogen on the product side. I have 8 hydrogens. So on the reactant side, I'm going to want to add that back in. So these hydrogen ions actually came from the acid, which we don't see because the acid was not oxidized or reduced. So I'm just done now with step 4 and 5, and now I'm going to balance the charges by adding electrons. So electrons, and you can see that overall on this side of this first oxidation reaction, I have a +2 overall charge. Over here, I want these to add up to +2, which would mean that I would have that 1 electron that is being lost in that oxidation. So -1 +3 is +2 total on the product side, and then this over here is +2. So we're equal, we just balanced charge for the oxidation. Now we're going to do the reduction. You want to start with the side that doesn't have the electrons, and you can see that water has no charge, but the manganese has a +2. So this product side is +2. So when I go to the reactant side, I want this to all total to +2. So when I do this, I have to think I've already got +8. I have a -1 from the permanganate. So then I'm really at a +7 at this point without any electrons, and I want it to overall be +2. So I'm going to add 5 electrons to make it so that the reactant side of this reduction is going to total to the same charge overall as the product side of this reduction. So by adding 5 negatives, here I have 6 negatives. If I add in the permanganate, then +8 from the hydrogens would give me overall a +2 charge. Now I'm going to make sure that my charges are conserved. So I want to make it so that I can cancel these electrons. And at this point, you can see that they're not equal. So I would need to multiply this oxidation reaction by 5. So then this would become 5 irons plus 2s, 5 iron plus 3s, and now I would have my 5 electrons when I distribute that 5 through. So I have 5 iron plus 2s, 5 iron plus 3s, and 5 electrons. So if I look at my steps, I just multiply the electrons by a factor so that they were able to cancel, and now I'm going to add those half reactions together, and I'm going to cancel any identical species. So I'm ready to add, and I'm going to cancel those electrons. And then on the reactant side overall, I have I'm going to highlight this for you. I've got the 8 hydrogen ions. I have that permanganate ion, and I have the 5 iron plus 2s. And on the product side, I'm going to have the 5 iron plus 3s, the manganese plus 2, and the 4 waters. So I'm just going to transfer that down, and I'm going to move this so that you guys can see it. So 8 hydrogen ions, the permanganate, the 5 iron plus 2 becomes iron plus 3 plus manganese plus 4 waters. So that's one problem, and I will solve another problem for you in the next video.